Okay, well today we will do section 5.4, which is going to be radicals. Wait, yes, that's right. Yeah. We're going to start radicals today. That's section 5.4. And what I mean by a radical is a radical number is a number that's under a square root. Okay, so we're going to start with a definition. The square root of a is the positive number that when squared equals a. Square root of a is the positive number that when squared equals a. I think you guys have all done square roots before. Most of you have. So square root of 9, we want to find what number would I square to get 9? What positive number? The answer is 3, right? Or I could do the square root of 81. And that's 9. Okay. But if I did something like this, the square root of 5, there is no whole number that when I square it gets me 5, is there? Because 2 squared is 4, and of course 3 squared is 9. So square root of 5 is somewhere between 2 and 3. So when we can't take the square root of something, we just leave it as square root of 5. We just leave it that way. Now you could certainly put this into a calculator, and if you put it into a calculator, you can get a decimal approximation. Okay, let me do that real quick here on my calculator. So if I do square root of 5, I get approximately 2.23606, and it keeps going on and on and on for all of eternity. And this number is called an irrational number. Whenever you can't get a whole number for the square root, okay, we call this an irrational number. So irrational numbers have an infinite pattern after infinite amount of digits after the decimal point, and they have a non-repeating pattern. Remember that rational numbers, which was fractions, we did last section, they either terminate after the decimal or they have a repeating pattern. Well, irrational numbers don't terminate, they keep going forever, and they do not have any repeating pattern guaranteed. Okay, so a great irrational number that you guys know is, well, now you know square root of 5 is one such number, but pi is an irrational number. That's a more commonly known. When we're finding like areas and circumferences of circles, we use pi. That's an irrational number. It goes on forever after the decimal and has no repeating pattern. Okay, so that's just basic definition of what a square root is. Okay, now we're going to introduce some other ideas. Okay, first idea is, if I have the square root of two things multiplied, I can break it up into 2 square roots multiplied. Oops. So an example of this would be that if I have the square root of 6, I could write that as the square root of 2 times the square root of 3. So almost, if you think about it another way, I could almost like make like kind of like a factor tree. So like if I had the square root of 12, I could divide that up as the square root of 4 times the square root of 3 if I wanted to. Or I could divide it up as the square root of 2 times the square root of 6 if I want to. Either way, those are both legal. So that's what this first rule says. Okay. Then rule number 2 is if I have a quotient, from dividing two things, I can divide that up as 2 square roots. Okay. Or I could actually go the other way around. I can go either direction on this equal sign. So if I had like the square root of 5 halves, I could write that as square root of 5 over square root of 2. Okay, or I'd have it the other way around. Let's say I said square root of 50 over square root of 2. Let's say I gave you that. Well, since it's division and there's 2 square roots, I could put it all under 1 square root. Well, what's 50 over 2? 25, right? Square root of 25 is just 5. So that would be my simplified answer for this original right here. Okay, so we're just beginning to build some theory here. Okay, so that's multiplying and dividing rational numbers, or radicals rather. So now let's look at some simplifying them. Simplifying radicals, okay? Well, we're going to use this idea that we can sort of like factor them to simplify them. Okay, so let's take an example here and then you'll see what I mean. So if I did square root of 8, well, we know that we can't take the square root of 8 and get a whole number because the square root of 3 is 9 and the square root of 2 is 4. So it's going to be somewhere between 2 and 3 is going to be this square root. But what I can do, you might agree with this, is I can break this up into 2 factors, square root of 4 and square root of 2. Because 8 is 4 times 2. But what's interesting about this is I can take the square root of 4. I can evaluate that square root and just get 2. Square root of 4 is 2. Notice it's not square root of 2 anymore because I evaluated the square root. It's just 2. And then I cannot simplify this because it's not a perfect square. Nothing, you can't square anything to get 2. So I just leave that under the square root. So that's my final simplified answer. So there's a strategy here I'm using is when I break up my 8 into 2 factors, I want to break it up into 2 factors such that at least one of them is a perfect square, because then I can take that square root and get some numbers that are outside the square root because I can evaluate that square root. Okay, let's do another one. The square root of 72. Okay, we're going to do this 2 different ways. So we're first going to do, let's find 2 factors of 72 where at least one of them is something I could take the square root of, evaluate the square root for, and get a whole number. Okay, so let's do square root of 9 and square root of 8. Okay, if I break it up as those 2 factors, notice I can take the square root of 9 to get what? 3. Square root of 8, right? But I'm not done. Why am I not done? Because I can keep breaking up the 8, can't I? Because I can leave the 3 in there. Whoops. Leave the 3 in there, and then change this to square root of 4 and square root of 2, which is what 8 is. So basically, I turned the 8 over there into square root of 4, square root of 2. But notice that square root of 4 is just 2. So this would be 3 times 2, and then I've got that square root of 2, which I can't simplify. So what's 3 times 2? I'm almost out of room here, so I'm going to go up over here. This equals 6 root 2, and that is my most simplified answer because I cannot take the square root of 2, nor can I factor it into two things. Okay? So let's try square root of 50. I want you guys to try that one quick. Go ahead and try square root of 50. See if you can break it up into two factors and then simplify it. So let's do this. This is the square root of 25 times the square root of 2. We know the square root of 25 is just 5, so this is 5 square root of 2. Well, you can write that in the feed you can write it like, so this is my answer, 5 square root of 2. Just write the number 5, then write SQRT with 2 in parentheses. That's how I would write that. You could write that, okay? Just so I can see if people got the answer. So like if another example is, if it was 11 square root of 7, you would write 11 SQRT of 7. Okay.
I have a quick question. So what if you broke it down differently?
Like how did you break it down?
5 and 10.
You can do that, but that doesn't really help you because neither of them is a perfect square.
Yeah, so I did the factor 2 and I was like root 5, root 5, root.
You've got to pick a factor that is a perfect square, otherwise it's a dead end.
Okay.
You know what I mean? So you want to keep looking for a factorization where you have at least one perfect square. And neither of these are perfect squares. So when you get to that point, that means you should go back to the drawing board. Does that make sense? And try a new factor pair.
Yes, thank you.
Okay, cool. All right. So let's do a couple more here. I'll give you guys a couple. Have you practice these and then we'll do them. So let's do square root of 80. Let's do square root of 250. Let's do square root of 192. And let's do 3 times the square root of 52. Work on those for a couple minutes and then we will do them. Okay, square root of 80. Well, I need to divide this into two things, one of which is a perfect square. Some of you guys did 4 and 20. That's okay. I'll do it that way because that's probably the most natural way to do it. It's not the fastest way, but that's fine. So this would be 2 times the square root of 20, but you're not done. The only problem with this is you're not done because I have to keep going because square root of 20 can be broken down a bit more. So this would be 2 times square root of 20, which is square root of 4 times square root of 5. Notice I always put the perfect square first if there's two factors, because I'm going to evaluate that perfect square and I want it next to this other number. So now square root of 4 is 2. So this is 2 times square root of 5. 2 times 2 is 4 square root of 5. So that's the answer to the first one. Okay, there's actually a faster way to do that. I'm going to show you that now. The answer is 4 square root of 5. We just did it the long way. The fastest way to do it is to recognize that 80 is 16 times 5. And that's really easy because square root of 16 is 4, so you get 4 square root of 5, which is the same answer we got before, but it was a little faster method. Okay, so that's what you should have got for that one. This one, I would break this one up as the square root of 25 times the square root of 10, because 250 times 10 is 25 times 10 rather is 250. So this is square root of 25 is now 5, and we're left with the square root of 10 under there because we can't take the square root of that or simplify it. So you should have got 5 square root of 10 for that one. Now this one is a little bit tougher. you got to play with your calculator maybe a little bit to find out some factors. You'll find out that if you divide 192 by 3, you get 64 and 3. Notice again, I put the perfect square first whenever I break something up. So the square root of 64 is 8, and then I have the square root of 3 left there. We can't take the square root of 3, and we can't break it down into any factors that will have a square root in them again. Square root of 3, the only factors of 3 are 3 and 1, and neither of them is a perfect square. Okay, this one's kind of a tough one here, this last one. We got to find two factors, one of which is a perfect square. Well, it turns out the one you want, we got to bring the 3 down, leave it in there, is square root of 4 and square root of 13. Okay, square root of 4 is 2. So this is 3 times 2 times square root of 13. Well, 3 times 2 is 6. So you should have gotten 6 square root of 13 for that last one. Some people may have broken this up as square root of 2 times square root of 26. That's a dead end. The reason that's a dead end is because I can't take the square root of either of those. And I only want to have one square root in my answer at the end. Okay, so you don't want to break it up with those factors right there. You want to use factors where one of them is a square root. Notice every time I broke it up, take a look with the red, anytime I broke up into 2, I always, at least one of them was a perfect square that I could take a square root of. That's an important pattern. So we're trying to find a factor that is a perfect square. Okay. Now let's use some more multiplication rules and play around with this a little bit. Okay, so if I take the square root of 12 times the square root of 2, I'll write another one down here, we'll do it in a minute. If I take the square root of 60 over the square root of 3. Let's do the first one. Well, square root of 12 times square root of 2, since it's multiplication in between here, I can combine this into one square root, 12 times 2. That was one of the rules we had just a few minutes ago. Well, what's 12 times 2? 24. Okay, now I need to simplify that square root. It's not simplified. Well, if you recognize, I could make this square root of 4 times square root of 6, because 24 is 4 times 6. Square root of 4 is 2. So I'm left with 2 square root of 6 is my simplified answer for that. Okay, we also had another rule back a little bit ago, where if I'm dividing 2 square roots, I can combine that into one division, one square root, 60 over 3, like that. That's one of the rules I wrote down. 60 over 3 is 20. Now I need to simplify that one. So I got to find some factors. Well, the square root of 4 and square root of 5 works. And again, remember, reiterating, one of them is a perfect square. One of them is a perfect square. You always want to have that pattern. So this now equals 2 square root of 4 times square root of 5. Square root of 5 cannot be simplified because the only factors of 5 are 5 and 1, and neither of them is a perfect square, so we wouldn't be able to split it up and simplify it at all. Okay, I'm going to have you try a couple like that here. I'm going to give you 2 of them. So look at this one. Square root of 90 over square root of 2. Try that one. And then the second one is the square root of 5 times the square root of 50. It's a bad 0. Try those and report your answers here as soon as you get done. Okay, looks like a lot of you are getting it correct. That's good. So the first thing I'd want to do is I want to take the square root of 90 over the square root of 2. Looks like the 3 square root of 5 and the 5 square root of 10 are correct, by the way. So this would be square root of 90 over 2, making it into 1, which is the square root of 45. Well, now I can break this up as the square root of whoops. This is the square root of 9 times the square root of 5. 9 times 5 is 45. Square root of 9 is 3 square root of 5. Okay, give me a second, Todd. Let's do this one, and then I'll answer your question. Give me 1 sec. So these are multiplied, so I can combine them into 1. This is the square root of 250. I can break that up as square root of 25 times square root of 10. We already did this one, right? Which is 5 square root of 10, because the square root of 25 is 5. Okay, Todd, what was your question? Okay, well, let's go into adding and subtracting these things. It's the next thing. Adding and subtracting radicals, okay? So there's a big idea with this, and the big idea is this is like combining like terms. Do you remember combining like terms with algebra? Okay, so this is like combining like terms. So I'll give you an example and show you what I mean by combining like terms. If I did 3x plus 4x, what would you tell me it was? You should tell me that it is 7x, right? So we just basically add 3 and the 4, right? Because we have 3 x's and 4 x's, which totals 7 x's. Well, look, I'm going to write something that's very similar to that. 3 square root of 2 plus 4 square root of 2. Doesn't that look very similar? The square root of 2 is in the x spot, so that should be 7 square root of 2 by the same pattern. Okay. Similarly, if I did 3x plus 4y, you tell me that that's just 3x plus 4y. You tell me I can't combine those because they're not like terms. One has an x and one has a y. So the same is true with square roots. If I had 3 square root of 2 plus 4 square root of 3, so this is like this x and this is like the y, then it looks like I can't combine those because they have different things that are different terms. So this would just be 3 square root of 2 plus 4 square root of 3. So it follows the same pattern as letters. Follows the same exact pattern as letters. Okay? So if I have 7 square root of 5 minus 11 square root of 5, what would I get for that? Well, I just take the 7 minus the 11, which gets me negative 4 square root of 5s. It's just like if I did 7x minus 11x, I'd get negative 4x. Well, in this case, the square root of 5 is operating like the x. All right. Now, where things could get a little bit weird is if I gave you something like this. Square root of 5 plus square root of 20. Those don't really look like terms because they don't have the same thing under the square root. So I can't combine them as they are. But what I can do is this one, I can go ahead on the side and simplify the square root of 20 to square root of 4 times square root of 5. I can take the square root of 4, which would give me 2 square root of 5. So now I can rewrite this whole thing over here. This is square root of 5 plus 2 square root of 5, which we just found out was square root of 20. So remember, even though there's nothing in front of the square root of 5 there, there's really a 1, isn't there? Just like when we have an x, there's really a 1 in front of the x. This is kind of like 1x plus 2x. So now what's 1 square root of 5 plus 2 square root of 5? That's a total of 3 square root of 5s. So sometimes it doesn't look like you can combine like those terms because they're not like terms. But after you simplify the square root of 20, you end up being able to combine them because they do both have a square root of 5 in them now. So this kind of uses the stuff from what we just did a minute ago. So if I map this out, let's try 4 square root of 12 plus 2 square root of 75. So what we probably want to do first is go ahead and do the 4 square root of 12 as its own problem, and do the 2 square root of 75 as its own problem, and then we'll eventually add them once we get those figured out. So this is 4, and then 12 is square root of 4 times square root of 3. Notice I always put the perfect square first because then it'll be close to the 4 that I'm going to combine it with. And then 70, I'm going to carry the 2 down. 75 is the square root of 25 times the square root of 3. 3 times 25 is 75. Both of these are perfect squares, which I can simplify. Evaluate. So this would be 4 times square root of 4, which is 2 times square root of 3. I wrote an 8 instead of 3. And so this is 8 root 3. This is 2 times 5 times square root of 3, which is 10 square root of 3. And I'm adding those, pulling this down. So 8 square root of 3 plus 10 square root of 3 is 18 square root of 3. That's 18 square root of 3. All right. Let me have you try a couple. So we will do 4 root 2 minus 5 root 2 plus 8 root 2. And then we'll try another example, which is square root of 50 minus square root of 18. Then we'll do another example, which is 3 square root of 18 plus 5 square root of 50. So try those 3 out. Take a little bit of time. Actually do it here. There's a couple different answers there. Some of you guys have a little bit different answers, so let's work through them. Well, first of all, this first one, these are all 3 like terms because they'll have a square root of 2 in them. So I really just got to combine the coefficients, or in other words, I got to combine the numbers in front, the 4, the minus 5, and the 8. So 4 minus 5 is -1, plus 8 is 7. So that'd be -1 plus 8 is 7. So this is 7 square root of 2, which most of you had that, or a lot of you did. Now let's look at the other ones. So in this one, we're going to want to do some side work here, okay? We'll do square root of 50 and square root of 18 as separate problems for a second, then we will subtract them in the end, okay? So this is square root of 25 times square root of 2. The square root of 25, we can turn to 5, so I get 5 square root of 2. 18, I can divide up as 9 and 2. I picked 9 because it's a perfect square. That's a 50, not a 30. So this is square root of 9 times square root of 2, which is 3 square root of 2. And I'm subtracting those. 5 root 2 minus 3 root 2 is 2 root 2. Okay. Yeah, if you kind of look, my 3's usually like, if you kind of look at those 2, there's my 3 and there's my 5. does look a little like a 3 if you're not comparing with my other one. Okay, so we got that done. So let's do this same over here. If I do 3 root 18 is 1, and then 5 root 50 is 1 problem. Okay, this is 3 square root of 18 is square root of 9 times square root of 2. I can take the square root of 9, which is 3. So this is 3 times square root of 2, because the square root of 9 is 3. So this is 9 root 2. This one is 5 times the square root of 25 times the square root of 2, because 50 is 25 times 2. So this is 5 times 5 square root of 2. So this is 25, and that's because the square root of 25 is 5, by the way. So this is 25 root 2, and I'm adding those. I go up here and notice I'm adding those two. 9 plus 25 is, whoops, 33. Whoops, that was a horrible square root symbol. So those are your answers. So does anyone have any questions on those? I saw a lot of different answers there. The last one, oh, sorry, 34. My bad. It's 34, yeah. That is correct. I added those wrong. 34, 9 and 25 is 34. So 34 root 2 should be the answer. A lot of people got that. So that's how we add square roots and subtract them. Okay, so we need to make them, they need to be like terms, which means that the root portion has to be the same in order for us to combine them, just like down here and here. Here we got the, and then here, and here the root parts were the same when we combined them. All right, take till 7 o'clock to have a brief break. Okay. Take a brief break and we will be back at 7 o'clock. Okay, we're going to get going back now, get back to the material here. We have one more topic in 5.4, and we're going to get into percents. That's our next topic. We're going to start, chapter 8 is all on personal finance, okay? It's all on personal finance. So we're going to tackle the beginnings of that today. But I'm going to finish up the last topic in section 5.4, which is, whoops, rationalizing denominators. I'll explain what I mean by that. So in mathematics, the big idea here is we don't like, I'll put like in parentheses, we don't like square roots, square root symbols in our denominators, fractions. We don't like square root symbols in our denominators. Okay, so as an example, 1 over square root of 2, we don't like that as a mathematician because denominators are hard enough to work with, let alone throwing a square root down in there. So there's a sneaky little trick we can employ that helps us to make it so there is no root in the denominator. There is no square root in the denominator. And that sneaky little trick is, watch this, I can take and multiply the top and bottom of this by square root of 2. Okay, that's legal because we know with fractions, we talked about last section, that we can multiply the top and bottom of a fraction by a square root, or by the same thing. So we can multiply the top and bottom by 5, we can multiply the top and bottom by 7, we can multiply the top and bottom by square root of 2. The square root of 2 is just a number. It's a decimal, granted. But what happens is when I multiply straight across on that, I get this is 1 times square root of 2 is just square root of 2 because 1 times anything is just the anything. 1 times anything is itself. But what is square root of 2 times square root of 2? Well, square root of 2 times square root of 2 is just 2. Here's why. Because square root of 2 times square root of 2 is really just square root of 2 squared, right? Whenever we multiply something by itself twice, we're squaring it. Well, the square root symbol and the square symbol are kind of undo each other, because squaring something is the reverse operation. So those two things, those two operations, squaring and the square root, undo each other. So in general, the square root of a times the square root of a is always just going to be a. So what I did essentially here, guys, is I took the square root of 2 over, I took the square root of 2 times the top and the bottom, and it ended up rationalizing the denominator, turning it into a rational number instead of an irrational number. Let's try a couple more of those and you'll kind of get acquainted with this. Okay, so take this example. 3 over the square root of 7. Well, I would just multiply the top and bottom by that square root of 7. And that gets me 3 square root of 7, 3 times square root of 7, over square root of 7 times square root of 7 is 7. Just like the reasoning we just did. So in general, the square root of a times the square root of a is just a. That's the general idea. I could get a little bit more complicated here in saying 15 over the square root of 50. Now I could multiply the top and bottom by square root of 50, but I'm going to give you a tip. It's actually not our best bet right there to do that. Here's why. You generally want to simplify square roots before you rationalize. Okay, so off to the side here, I'm going to go ahead and write the square root of 50. I'm going to simplify it. That's square root of 25 times square root of 2. I can take the square root of 25 to get 5 square root of 2. So now I can rewrite this. This is 15 over 5 square root of 2. The reason why that works out real nicely is because the 15 and the 5 can reduce. Divide this by 5 and I get 1. Divide this by 5 and I get 3. So I end up with 3 over the square root of 2, which is way easier to work with, smaller numbers. To rationalize that, I just multiply the top and bottom by that square root of 2 so that this bottom turns into a rational number. So this is on the top 3 times square root of 2. On the bottom, square root of 2 times square root of 2 is just 2. That's the final answer. Okay, let's have you try a couple of these and go ahead and write your answers. We're going to do 21 over the square root of 7. We're going to try 30 over the square root of 5. And then we're going to try one more example. 13 over the square root of 40. So give those a shot. So let's start with this one. This is the easiest one. We would just do square root of 7 over square root of 7. So this becomes 21 root 7 over 7, right? But the 7 and the 21 can reduce 1 and 3. So I end up with just 3 root 7 for that one. Over 1, and the over 1 just means we don't need to include it. 13 square root 10 over 20. We'll see if that works out. So let's try this one. Square root of 5 over square root of 5. Well, this would be 30 square root of 5 on top. Square root of 5 times square root of 5 is 5. The 30 over 5 can reduce to 1 and 6. We can divide them both by 5. So I end up with 6 root 5 on that one. Those two didn't even end up with denominators. Okay, now the 13 squared 40, we should probably simplify the denominator first to square root of 4 times square root of 10, which is 2 root 10, because I can take the square root of 4. So this is 13 over 2 root 10. Now, in order to get rid of that square root of 10, all I got to do is multiply the top and bottom by square root of 10. So on the top, I get 13 root 10. On the bottom, I have the 2 there. And then the square root of 10 times the square root of 10 just turns into 10. So this is 13 square root of 10 over 20. That is my final answer. And that's what John just got, 13, and some other people got that as well. Okay, so that's how we rationalize. The trick, guys, with rationalizing, if you look at the pattern, I always just multiply the top and bottom by whatever the root is on the bottom. See that? So this matches with that. And then there's a root, and I multiply top and bottom by that root. That's a pattern we're using. Whatever the root is here, and here, and here, I multiply the top and bottom by that root, and that ends up turning my denominator into a rational number instead of an irrational number with a square root in it. Okay? All right. With that, we're going to begin looking at percents. We're going to jump to chapter 8. Personal finance chapter. Section 8.1%. So first of all, percent is a Latin word, has a Latin root. Per cent. Okay, it's 2 words, per and cent. Okay, which means per 100. Cent means 100. Per means per, like as we do in English, like $50 per ticket, $50 per ticket. So per 100 means out of 100. So if I say a percent, that means a over 100 in fraction land. So for example, if I say 37%, that means 37 over 100. That's how we change it over to a fraction. If I say 0.5%, that means 1/2 over 100. You just take whatever you're doing, whatever number you have in front of the percent, and you go ahead and put it over 100. Whether it's a whole number, a fraction, or I could even do a decimal. I could do 3.2%, and that just means 3.2 over 100. Okay, so that's what percent means. The reason we like percents is because it's easier for us to think in hundreds as far as a subdivision. So it's actually a pretty nice way to think about things. All right, so let's take a look at when do we use percents? What do we use them for? Well, obviously, the applications for percents are all over the place, right? We use them for buying, for figuring out interest rates on loans, for figuring out how much we're going to make in a savings account. We use them for markups. If we're on a clothing store and we're going to mark up our clothing, we'll use a percent to mark it up. Sales tax, John said, correct. Any kind of tax, in fact. if you go to the Columbia store at Birch Run, and there's a 30% off discount, you're using percents there. Percents are extremely relevant to everyday life. So we're going to get some practice with working with them. So let's start with, how do we change a percent to a decimal? Let's start with that. So if I give you a percent, how do you change it to a decimal? So the big idea here is if it's a percent to a decimal, we move the decimal point two places left. 2 places left. Okay, so for example, if I say 32%, well, the decimal point is right there in 32, isn't it? And anytime we have a whole number, the decimal point is furthest right. So if I move it to the left, I would get 0.32. So this is the decimal, and this is the percent. Okay. Think another one. What if I said 0.01%? Well, if I move that to the left, if you imagine me moving it to the left, 1, 2, I'd have to add a 0 there, right? So I would get 0.0001. Again, that's the decimal. That's the percent. The green part is not the percent. That's just my work shown to get the right side. What if I said 5.3%? If I move that to the left 2, I should get 0.053. Notice that on this side, there's no percent signs because I changed it to a decimal. So whenever you're changing from percent to decimal, you move it to the left and drop the percent symbol. Okay, that's percent to decimal. Now, what's decimal to percent? Obviously, it's pretty easy because you just do the reverse that we did. So the idea here is to move the decimal point two places right. Okay. So now, if I give you 1.287, that's a decimal. As a percent, that'd be 128.7%. I move it 2 to the right, 1, 2. I could go 0.0371. If I move that 2 to the right, I get 3.71%. 1, 2. Okay, so those are just some real, this is just a refresher of stuff you already in theory know. Okay, let's talk about next, then we're going to do some problems, percent equations, now that we've got those basics down. Percent equations. So I'm going to give you some translation cues, and you're not even going to understand what I'm talking about until we do a couple problems, then you'll get it. For percent equations, is going to translate from English into an equal sign. Of is going to translate to a time sign. And what or find will translate into my unknown. That makes sense, right? If I say what, I'm going to rewrite that because handwriting was so bad. That's still terrible. I don't know why I care about that. What or find is going to translate to X. Okay, so let's take an example and I'll show you what I mean by this. 15 is 50% of what number? 15 is 50% of what number? Well, the answer is going to be 30 because 15 is 1/2 of 30, which would be 50% of it. But there's probably you can't really do in your head as easily as that one, even though that one's not easy to do in your head necessarily. But what we can do here is we can write this as an equation. Okay, I'll show you what I mean by that. Write down the 15. Is means equal, following the cues up above. So the equal is means equal. 50%. So whenever I write the percent in the equation, I want to write it as a decimal. So 50% written as a decimal is 0.50 or 0.5. I don't need to write the 0. Of means times, looking at the cue right here. And then what number? Well, that's the x. 0.5 times x. And in all these equations, we're just trying to solve for x. Well, if I have 0.5 times x equals 15, how do I solve? Well, I'd divide both sides by 0.5, wouldn't I? Then you can just do this on your calculator, this part right here. And 15 divided, and then they cancel over here. So x is going to equal 15 divided by 0.5, which is 30. All right, let's do some more of these. So 18 is what percent of 48? Now we're going to round this to 2 decimal places. Any problem we do, we're going to round to 2 decimal places for today, okay? So let's write out the equation. What would the equation be? Well, it'd be 18 is equals what percent? That's my x, right? My unknown of is times 48. So how do I get x by itself? I would divide both sides by 48, right? And when I plug 18 over 48 into my calculator, that is 18 divided by 48, I get that x equals 0.375. Now that is not my answer because they asked at the beginning of the problem, what percent is, that is the decimal. How do I change it to the percent? I have to move a 2 to the right, don't I? Since they asked for a percent, remember in the equation, in the math land, this is math land, the percent's always going to be in decimal form. So we have to change it back to percent form to get back to our answer. Okay, how about this one? I'm going to give you a couple to try. Give me a minute, I picked a couple out here. 32% of what is 51.2? That's one. Let's do another one. What percent of 7.5 is 0.6? So just take a second to try those, translate them first, and then solve for your x. And we'll do them in a minute. So what percent of 7.5 is 0.6? So first of all, this what percent is my x. X of translates to times. 7.5 is translates to equal. Equals. And then 0.6. To get the x alone, I have to divide both sides by 7.5, don't I? Which that gets me x equaling 0.6 divided 7.5 is 0.08. That's not my final answer because remember, they asked me for what percent. And in the math land, this is going to be in decimal form, so I have to change it to percent world land. 0.08 is 8%. So your answer should be 160 and 8% are the two different answers. Okay. So now let's just do some practical examples using percents. If you buy a car, I just bought a Toyota Camry this last weekend, or not yet last weekend, yesterday actually I bought it. Went down to Detroit and picked it up at a car dealership. And if you buy a car that has a purchase price is $8,700, okay? So you buy a car. Sales tax, 6%, okay? And then let's also say that there is a luxury tax, which some states have. Which is 1.5%. What I want you to do is to find, and then your tax, right, my bad, your title and license is 176.85. I want you to find the total cost of that car out the door. So take a minute to use your percents, find your sales tax, find your luxury tax, and then add your tax, your title and license to that. And I want you to figure out, take a minute to figure out the out the door price for that. So first of all, to find the sales tax, using colors just for fun. To find the sales tax, we would just take the purchase price, $8,700, and we would multiply that by the sales tax, which is 0.06. Okay, let me get that. I'm gonna pull my calculator out here. 8,700. That's $522. Okay. Then we do the luxury tax. That's $8,700 times 0.015. And that's $130.50. And then we add the tax title license to that, which is 176.85. We add those up on the calculators, fine. 522 plus 130.50 plus 176.85 is 829.35, and then I'll just add that to the 8,700. And I do get what most of you guys had, 95.29.35. Okay, just very, very simple application of that. Very simple application of that. Okay. Let's do some harder ones then. So let's talk about, well, let's before we do the harder ones, let's talk about percent increase. So if you mark something up or you have a percent increase, okay, what's the formula for percent increase? Well, the formula for percent increase or a markup is the amount, whoops, let's write it another way. It's the increase amount divided by the original amount. Okay, and then we have percent decrease. So if we're going to have a sale, that'd be a percent decrease. We're decreasing the price. That would be the decrease amount divided by the original amount. Okay. So the increase amount divided by the original, and then the decrease amount divided by the original. Let's do a couple examples here. Okay, let's say the price of gas increased from $2.43 per gallon to $2.59 per gallon today. Let's find the percent increase. Okay, so the percent increase would be the increase amount divided by the original amount. Well, the increase amount's really easy to find. You just take 259 and subtract 243. That's how much it increased, divided by the original amount, which is 243. That's what it started at. Let's do that on the calculator here. So that would be 259 minus 243, and divide that by 243. And I get 0.06584 going on and on. But that's not my percent because I need to change it to, this is in decimal form, you change it to a percent. So the answer is going to be, if I move the decimal over 2 to the right, looks like I'm going to get 6.58% if I round it to 2 decimal places after I move the decimal point. So that's a 6.58% increase in the price of gas today. Okay. So let's say now a backpack sells for $48.99 normally. It is on sale for $32.99. Find the percent. I'm not going to write the question. Let's find the percent decrease. So percent decrease would be the decrease amount divided by the original amount, which in this case is, the decrease amount is $48.99 minus $32.99, whatever that is, all over the original amount, which is $48.99. That was the original price. So $48.99, let me just do this here quick. $48.99 minus $32.99 is $16.99, right? And I'm going to divide that by $48.99. And that looks like it's approximately, I'm rounding, 0.32659 and a bunch of dots. So if I move the decimal point 2 places over, it looks like I get 32.66% is the discount. So it's roughly 33% off, or 1/3. That's roughly 1/3 off. Okay. So let's try another one. Have you guys try one, okay? Price of rice dropped by 35% this week. It used to be $2.50 per pound. What does 4 pounds now cost? Okay, go ahead and try to figure that out. We'll be back in a minute to do this, but write your answer in there and see if we can get this. Let's do this one. Well, first of all, the price dropped by 35%, and it was $2.50 a pound, right? So I have a couple ways I can do that. I can find out what 4 pounds cost before. So let's do it that way. So before, so let's do this here. Before, the cost of 4 pounds was $2.50 times 4, $10. Okay. Well, now the price of rice has dropped by 35%. So let's find out what the drop is, or the discount now. That'd be $10 times 0.35, right? Because the price used to be $10 for those 4 pounds, and it's dropped by 35%. 10 times 0.35 is 3.5. $3.50. So before it was $10, there's going to be a $3.50 discount. So my new price is going to be 10 minus $3.50, which is $6.50. Okay. Another way you could have done this, and you get a little bit of error, is just because you have to round more, is you could have started with doing this all per pound. Okay, but you'll get a little bit of rounding error. I'll show you why. So if I could do the before, I could say was just 250 cents. We'll just do it by pound for now. Then at the end, we'll multiply by 4. Then the discount, we'll just do it as for 1 pound, would be $2.50 times 0.35, which is 2.5. Let me get that figured out. 2.5 times 0.35. That is $0.875. Normally you round that to 88, but let's just leave it as it is so we don't have rounding error. Then I just I need to take the 250 and subtract off the 0.875. And I get, for 1 pound now, after the discount, is $1.625. And I'm just carrying the 5. It doesn't make sense to, because it really should be $1.63. But I'm carrying the 5 so I don't have rounding error as I do all this stuff. So now 4 pounds, 4 times 1.625 is $6.50. So where you could have error in this, guys, is if you rounded it here to 88 cents, you get a little bit of rounding error, but I still would probably give credit for that just because you're doing the procedure right. No problem, John. It's not a big deal. Okay, let's take a 5-minute break, and then we're going to come back for a little bit and do a couple more problems. So just take a 5-minute break to 8, okay? Okay, I've got a problem up here I want to do that just combines a couple percents. What is the total cost of a $720 iPad that is on sale at 15% off if the local sales tax is 5.25%? Okay, so why don't you guys try that? Maybe you've already done it. Melody said 575. That might be correct. I haven't done the problem yet. But I'm going to give you guys about 2 minutes to do this. Then I will come back and do it. So take a minute to try to do that. My hint is you want to figure out the sale price first and then do the sales tax after that. So go ahead and give it a shot. Okay, I'm seeing a lot of answers there, a lot of disagreement on what it is. I think 644.13 is the correct answer. I think John got it. So Sandra K. And so let's work through it. So first of all, we first want to apply this 15% off. Okay, so we got to find out what the discount is first. The discount is going to be 720 times 0.15 since it's 15% off. Okay, and 720, so it's my calculator, times 0.15 is $108. So that means that the sale price is 720, the original price, minus the discount, 108, the 15% discount. Okay. Which is, I'm just doing that, $612. So that's the sale price. So that's what that's the cost of the iPad. Now I want to find the sales tax. The sales tax, which would be the sale price that I just found, $612, times the sales tax rate, 0.525, because I got to move the decimal place 2 to the left because it's in percent form. So I take that 612 and I multiply it by 0.0525, and I get $32.13. Okay, so now I know the sale price here, and I know the sales tax. So I need to add those two because I got to take the price of the iPad and add the sales tax to it. So my final answer is 612 plus 32.13. Which is 644.13. That's how I think through that. I first found the discount. And then I found the sale price by subtracting the discount off. Then I calculated the sales tax on the basis of the sale price, which is what would happen. And then I added the sale price and the sales tax together because the sales tax is an additional fee. No problem, Melody. It happens. So that's a good two-part problem. You're going to encounter some problems like that one in the homework. So the last thing I'm going to do tonight is I'm going to briefly introduce income tax. We're not going to do 8.2, but I'm going to briefly introduce it because there's got a lot of sections next week. So I'm going to briefly introduce the basic terms for income tax, okay? There's some big ideas in income tax, okay? The first big idea is what we call your gross income. Gross income that's your total income for the year. So we're going to start introducing some income tax stuff here, guys. That's your total income for a year, okay? So that's income before taxes. So if you make $50,000 a year, this would be your $50,000. Okay. Now we have a couple other terms we're going to use, which is adjustments. There are adjustments to your gross income that are used to figure your taxes. Okay. Your adjustments are your exemptions plus your deductions. Okay. So what are exemptions? So an exemption is a fixed amount on your return for each person supported by you. By your income. Okay, so for example, in my household, my income supports my wife and my two daughters. And so I get a fixed amount on the basis of having a wife and two children. I get a fixed amount that I do not have to pay taxes on, that I can subtract out of my gross income, okay? Now let's go on to what's a deduction. So deductions, okay? There's two types of deductions. There's the standard deduction. Or you could have what we call itemized deductions. Okay. On your tax return, you've got to choose which one you want to use. And what you want to do is you want to choose the one that's bigger, because then you get more of a deduction. The standard deduction is, again, this is a lump sum assigned amount. So the standard deduction is a lump sum assigned amount. The itemized deductions are are qualified deductions you list and add up. Okay, that's what itemized deductions are. So when I do my taxes, because I have a wife and two kids, because I'm married, I get a standard deduction amount, something like $17,000 or $18,000 that I can deduct, which means I don't have to pay taxes on that portion of my income. Okay. If I gave a lot of money to charity, and let's say I gave more money to charity than my standard deduction, then I could choose to do an itemized deduction because charitable giving is deductible. So like I said, you're going to choose between the standard deduction and the itemized deduction on the basis of which one's going to be bigger for you, because that's more that you get to deduct from your taxes. Now, things that fall into itemized deductions would be things like charitable giving, home mortgages. If you have a mortgage on your house, all the interest from your mortgage is deductible. State income taxes are deductible. Property taxes can be deducted. Charitable contributions, medical expenses can be deducted. So there's a lot of different things that can be deducted under the itemized deductions category. Okay. So we're going to use all these terms to get a big number that we need for our taxes, which is called the adjusted gross income. And the adjusted gross income is the income that is used to figure out your tax bill for the year. The adjusted gross income is your gross income minus any adjustments you have. Okay. And I could actually write this out. There's two types of adjustments you're going to have. It's gross income minus your exemptions plus your deductions. Okay, so your adjustments is essentially your exemptions plus your deductions. So that's your adjusted gross income. It's going to be your gross income, which is all the money you made, minus your exemptions plus your deductions, which is your adjustments. Okay, so this whole thing, whoops, adjustments, and this is what adjustments really is your exemptions plus deductions. Okay, your deductions, you're going to have to choose between itemized and standard. And you choose the larger one. Okay, because that gets you more of a tax break. Okay, so that's a brief introduction. And so what I'm going to do is I'm going to stop there and give you guys some extra time to do some homework and some practice. We're done for the night. We're through everything I wanted to get through. So we're going to hit 8.2, 8.3, 8.4 next class. They're actually not super long and not super complicated. And then look for a review soon. I'm going to try to get that posted by the weekend so you have some time to start working on it this week, even and asking questions by Wednesday. Wednesday's going to be a big review day. We're going to go over several things on the review. So do you guys have any questions?